Okay, we're going to take a slight turn to the left for a second, and we're going to talk about WebGeocalc. This is a separate tool that, as was mentioned yesterday briefly, allows one to make many kinds of, well, let me just start going through the slides. So this provides a graphical user interface to a geometry engine running on a SPICE server. And Nafe has one running at JPL, and Mark has one running here, as he mentioned yesterday. This set of slides is going to talk mostly about the one at JPL. There's a few differences with regards to the one running here, and Mark will mention those when he does a demo right after this tutorial. So this server has access to all of the kernels that are available at JPL in our case, and it makes it rather easy to make a whole variety of typical SPICE computations. But the downside is, there's two downsides. One is it can only make computations that we have programmed into the WebGeocalc tool, which is a lot, but it's not nearly as much as all of SPICE can do. So there's good and there's bad. A second limitation is it only has access to the kernels that we have on our server, or in the case of ESA that Mark has on his server, which may not be some kernels that you would want to use, particularly if you're working on a brand new mission that hasn't yet put data into the Nafe or the ESA system. That said, here's a little picture of it. Again, all you need is your computer, connect to the WebGeocalc server, you send a question to the server, and it thinks and computes, and if all your inputs were acceptable, then a few seconds later your answer comes back and is displayed in your web browser, just as simple as pie. It makes it easy to do lots of computations. You select the computation you want from the menu, input various inputs that are needed in order to refine your question, time frame and objects and so forth, and finally punch the calculate button and boom, the answer comes back. Now, WebGeocalc will do three kinds of computations, sort of like all of SPICE does. First, there are what we call the geometry calculator computations. These are the old style Nafe computation or SPICE computations. Compute something at time t or at a bunch of time t's from start time to an end time. And then it also can do the opposite side that we talked about yesterday, the geometric event finder. That is, find the time intervals within a confinement window, find the time intervals or discrete times when a particular geometric condition exists or when a geometric parameter is within a specified range. And thirdly is time conversion, so it can do almost any time conversion that our subroutines can do. This is the computation menu. You don't have to memorize it here, but it shows that we have the geometry calculator calculations here. Here's what's available. Here's the event finder calculations and time conversion. We are working to add a few more computations in a new release that should be coming out rather soon. This is just a graphic illustrating a few of the kinds of computations that you can do. Here's angular size at a given time. Here's illumination angles at a given time. And this is a geometric event finder computation. Find the times when the camera, when the instrument bore sight is greater than 30 degrees within this time range. So here's the input menu for a typical geometry or geometric parameter calculation. You first select the data set that you want to work with. And in this case, we selected, well, first we selected from the menu what computation we wanted. In this case, it was angular size. Then we select the data set that we want to work with. And then based on this computation, all of these menu items are set. In this case, we have to say what object we're interested in looking at and where we are observing from. We talk about aberration corrections. We talk about the time or time steps that we want to make the calculation. And there's some optional plots that you could ask for. And then down here you punch the calculate button and boom, there comes your answer. And it starts off with a summary of the inputs that you gave, just so you'll remember what you did. And then here's the numeric results. In this case, it was the angular size of Phobos as seen from the Mars Spirit rover over this time range here. I said there are, in many cases, optional plots. In this case, angular size has an optional plot, and this is, in fact, a plot of that numeric data. You can save this plot. Comes out as a PNG file, so it has a clear background, and you can very easily paste it into a PowerPoint or some document or some place that you want to keep it. Here's another example of a plot which is not something that versus time. In this case, it was latitude versus longitude. So there's a variety of different plots that are available. Here's a geometric event finder input panel. It's very much like the geometry calculator. In this case, we're finding the times when Phobos is occulted by Mars as viewed from the Mars Odyssey spacecraft during this particular confinement window. And the output is very similar to the geometry calculator. You have a summary of the inputs that you used, and then here are the intervals, the time intervals that meet your criteria. So it's a start time and a stop time and the length of that interval, giving the answers of when this occultation condition existed within that confinement window that you started with. You also get a plot showing those intervals in a graphical form. And finally, here's the time conversion window, also very similar now. You put in a time system and an input time. In this case, we're talking about a spacecraft clock time, and we want to see what is the corresponding UTC time. And I guess the output doesn't show here, but this is what the output for that particular calculation was. So as you've heard earlier, for the NAIF server, we have three kinds of kernels available. This is where it differs a little bit from what Mark's got available. We have generic kernels, that are independent of any particular mission. We have the archived data sets from all of the NASA missions and a few ESA missions. And we have the operational kernels. So the way you use these different kinds of data varies somewhat, and it's very, very important. If you're going to use WebGeocalc, I can't tell you how important it is to read this little document called About the Data. There's a link to it within the tool, and if you don't read that about the data, you're going to get angry at NAIF and at Mark and the world, and you're going to crash your computer, and you're going to go raise potatoes. So read about the data. That's it. Here's an example of the kernel selection input menu. Again, this is a JPL. Here you can see the generic kernel sets that we have available. Here we have the some of the archived data sets, and here's manual selection, and this is used for the operational kernels. If you select from the archived kernel sets, this tool works very, very nicely and easily because meta kernels for those archive data sets have been loaded, and a lot of information is provided to the tool. You'll see some of that in just a moment. If you're going to use operational kernels, you have to then know which specific kernels to load, one by one by one, whereas if you're using the archive data set, you just load the meta kernel and boom, everything is there for you. If you hover your cursor over the name of one of these data sets, you'll see a little pop-up tool help tip that shows you the time frame that this data set covers. And this is one of the key problems that people have. They don't pay attention to the fact that the stop time is typically 3 to 6 to 9 months or even more past real time. So you're trying to do a computation for, let's say, Mars Express during the year 2021. Well, it's not going to be there. So you really want to pay attention to the time frame covered by the archived data set. If you use an archive data set, then this autocomplete feature is available, and you can type in a few characters in many of the input parameter items, and immediately you'll see a list of all of the available items that match what you've typed. So here I typed MI, and it turns out for the Cassini-Huygens mission, there are 3 objects. One of them is Mimas, and 2 are strange asteroids, I guess. And so that makes it much easier for you to know what objects are available in the kernel set you've loaded that can be used in the computation. You can download the tabular results to your computer in 3 different formats for use in another tool or just for saving in a document or saving for whatever purpose. You can also download the plots, as I've already mentioned. You can save a numeric output in a little side column, which you can then drag back into an input on a subsequent calculation. So you can, let's say you found an angular size, and then you want to use that in a subsequent calculation. You can do that within the tool. Perhaps more importantly, if you're using Geometric Event Finder, you can save a complete set of Event Finder output intervals and then use those in a subsequent calculation. And I'm not going to go into these details now. They're explained in the online tutorial. But this is a way to have what we call cascading computations. You do a quick and easy search first to find a small subset of windows that might match your ultimate condition, and then you use that set of windows as an input to a much more labor or time-intensive calculation to find the actual quantity that you want. So you can cascade 1, 2, 3, multiple times. Once you start trying WebGeocalc, you'll find this is a very, very useful feature. And as I said, see the online version for more information and also about the typical problems that people encounter in trying to use WebGeocalc. There is some help available in the tool. Again, read about the data. That's very important. Every parameter input has a little help icon, and if you click on that, you'll see a pop-up window that will give you some indication of what we're looking for there. And in some cases, there's 2 levels of pop-up windows. Also, for each calculation, there's actually a graphic that shows the kind of calculation that will be done. So I've said these 2 things. Because we provided all of this online help, we hope people will actually make use of that rather than immediately send an email saying, oh, WebGeocalc doesn't work and it's broken, and help me with this or help me with that. In the end, if you're really stuck, please send the email to Mark or to Mark's new person who's going to be hired shortly, or to one of the NAIF guys, and we always try and help answer questions, whether it's about WebGeocalc or anything else.